8 and... So the first one is 8, and I do about second one.
11, 2.
So I mean, like the top is 8. An idea what's on the bottom.
2. Oh, minus 2.
Let's see. Yes, minus 2, I believe. Yes, so it's just from A to B. So it works like a normal vector. And these two are position vectors.
Okay.
8 minus 2, so they wrote it in I and J notation. Same thing. We'll do I and J. Okay, how do we do this?
So, well, the position vector would be all that. Will that be minus 3, minus 4?
So if I go back a second, so this one, how did we get A to B? How did we do part C?
We went across and then down to B.
So we went from A to O, and then O to B.
Right, yeah.
And so another way of saying that is minus OA plus OB.
Right.
And then just to kind of make it look a bit more normal, that would be O to B minus O to A. And so you can use that, or you can always just do a sketch. So is there any way we can use this one?
So 3i plus 4j is equals to 5i minus 2j.
Hang on, so it is O to B is the same as the position vector of B, starting from the origin.
Yep.
Minus O to A. Okay.
Oh, and then do I need to expand the brackets and then just take and then get OB on one side of the equation?
Mm-hmm.
So would it be 3i plus 4j equals to OB minus 5i plus 2j?
Yeah. And
then will it be 8i plus 2j equals to OB?
yes. Let's see. So A to B is the same as O to B minus O to A. If you're stuck, O to A is 5 minus 2. So you could say that is O to A. And then A to B, that's 3 right, 4 up. So maybe that's about there. And so you could just do your sketch and do it that way if you needed to. 3i plus 4j, 5i minus 2j, and so from O to B you would do that and that. Let me think about this actually. The position vector of B is O to B. O to B. It looks like O to A plus A to B this way. Oh, that is the same thing. 8i plus 2j. Yep. Great. How about part B?
So will that just be square root 8 squared plus 2 squared?
Yeah.
And so that will be 2 root 17.
2 root 17, is it?
Yeah.
Okay, great. Great. Yes, and we can use this thing. Okay, any questions there?
No.
Okay, so position vector starts from the origin. Position vector B is O to B. Position vector A, O to A. Oops. Okay, we'll try this one.
So, um, okay, so when it says position vector of B, but I need to do something like 3i plus 11j
Yeah.
equals to OB, and then plus -1, -7, -6.
I'll leave it minus that one. Oh, sorry. Yeah.
And then I need to expand the brackets and get 7i plus 6j.
Mm-hmm. And then?
And then I just need to get OB on one side. So would the answer be -4i plus 5j?
Yeah, that's it. And before we look at anything else, using this little diagram, I found there's actually a much easier way. So O to B is the same as O to A and then A to B, and so
Sorry,
you can just directly add them. O to A to B,
okay.
and so if you go from O to A and then A to B, that's the same as going from O directly to B. And so -7 plus 3 is -4, and -6 plus 11 is +5. So I'll make things easier. What would you do for B?
So would you then do square root of minus?
Can you hear me? I think your audio cut out. Hello? I can't hear anything.
Yeah. So will it just be -4 squared plus 5 squared?
Okay, so try that in your calculator, see what you get.
I've got root 41.
And let me just see. I think that is not correct, believe it or not. No, it is correct. Yes. And so I just did a simple way, which is 4 squared plus 5 squared root 41. Same thing. Good. Let's see this one. Okay, let's try this one.
Okay. So sorry, I'm just writing out quickly. So uh, Okay, sorry about that.
Sorry.
So, y equals 6 minus 3. So, would you have to do something like it equals to root 53? So, does that mean wait, is it like y is equals to I and no y is equals to j and x equals to I, or is that not correct?
Yeah, they roughly sync up. Yeah, and because it starts from the origin. Yeah.
So do I need to do something like root 53 equals to square root x squared plus y squared, or
Yeah. X squared plus y squared.
so does that mean that 53 equals to x squared plus y squared?
Yeah. 53.
So I'm not really sure what to do, to be honest.
Me neither. Let's see. So it has to be along the line y equals 2x minus 3. So you have the line y equals 2x minus 3, which is like that. That's minus 3. It's going up by 2 each time. So what squared plus what something else squared gives you 53. And there's a group of coordinates. So let's say when x is 0, y is minus 3, but that squared would give us 9. 53. Let's try, if you had 25 and 25, let's say try 6. When x is 6, oh, that might be way too big. Let's try when x is 5. When x is 5, that would be 10 minus 3 is 7. That might be too big. 5 squared plus 7 squared. Yep. Let's try one.
How did you get 0 minus 3, sorry?
I just subbed it into y equals 2x minus 3.
Okay.
So when x is 0, y equals 2 times 0 minus 3. When x is 5, y equals 2 times 5 minus 3. So let's say when x is 3.
So if x is 3, does that mean that y will just be 3?
Yeah. Let's try 4. So I think it's 4, 5. No. And 5 was that. So maybe it's let's think about this. So 4 squared is 16. 5 squared is 25. So there'll be 53 is like 25 plus 28. Maybe it is 5 and 7. No, it can't be. That's 25 plus 49. So we must be dealing with some kind of decimal. What is the method though? Let me see this one. Minus 2 and minus 7. But where do they get these answers from? How would you know it's minus 2 and minus 7? There's no... Is there some kind of... Oh, maybe it's simultaneous equations. That's it. Simultaneous equations. So you know how x squared plus y squared equals 53?
Yeah.
The other equation would be y equals 2x minus 3.
Oh, right. Yeah. And so you sub in the 2x minus 3 into the y squared bit.
Yeah.
And then you get x squared plus 4x squared. Uh, minus 12x plus 9 equals to 53. And then would you do make it equals to 0, so do x squared plus 4x squared,
And what is x squared plus 4x squared?
5x squared,
Mm-hmm.
minus 12x, and then minus 44 equals 0. And then yeah, I got x is equals to 22 over 5, and the other x is minus 2.
And so how do you get the y?
Sub those things in.
Yeah. Into which one?
Y equals 2x minus 3.
Yeah, that's the easier one. All right. So that one is minus 7, definitely.
So
And this one I think is 29 over 5.
yeah,
So that's 29 over 5. Now we were calling them x and y. They're calling them p and q. And so in that format, yeah, 22 over 5 I plus 29 over 5j and so on. So yeah, it was just basically simultaneous equations, quadratic simultaneous equations. So we had two unknowns, so we had to find two equations. Any questions there?
so it's either so there's two unknowns here. That's just what I'm confirming, basically.
Yeah, so we knew from the start it's going to be like x squared plus y squared is 53, square root thing.
Yeah.
And then I was just trying to like, how are we supposed to know which was which? But then I realized there's actually a second equation.
Yeah.
Yeah, and so two equations, two unknowns. Great. Let's see. Okay, let's try part A for this one.
So will that be just 10i minus 2j?
I think this one's slightly different. Before we were finding OB. This time we have to find AB.
Will it be something like 4i minus 5j plus minus 1 6i plus 3j, or?
It'll be something like that. It's a position vector, so it starts from the origin. So let's say this one is A, and how would you do B? What would that look like?
So there'll be like 6 across and 3 up.
And where does it start from?
The origin.
Yeah.
So from A started. Yeah.
Yeah. Okay, so how do we get AB?
Do we have to join up that? Oh wait.
Yeah, that'll work.
Yeah. And then so will it be so 4i will it be 4i minus 5j? So, will it be minus 1 times 4i minus 5j plus 6i plus 3j?
I think I might have drawn this vector the wrong way actually. So if this one is A and the other one is B, so that's A. So we want A to B. So what was it again, sorry? We're going from A to B. .
will it be minus 1 4i minus 5j plus 6i plus 3j? Or I'm not really sure.
Yes. Did you say minus 1 for I minus 5j, like that?
Yeah.
And then plus the other one. Yeah.
Okay. And then I'm just trying to draw this. So and yeah, and then so minus 4i plus 5j plus 6i plus 3j.
Mm-hmm.
And then will it just be 2i plus 8j?
Yeah. 2i plus 8j. And so I think for these, let's just sketch it every time.
Yeah.
The formulas move around too much. B is just Pythagoras. 2i plus 8j. Okay. Ooh, let's try this one.
Okay. So the point A lies in circle equation. So could you do something like two? Could you sub in 2k into x and then sub in k into y,
Okay, yeah.
and then you'll get 4k squared plus k squared equals 9, which will be equals to 5k squared minus 9 equals to 0.
Mm-hmm.
And then can I just put that into my calculator?
Yep.
And then will the answer just be k is equals to 3 root 5 over 5,
Mm-hmm.
or minus 3 root 5 over 5.
And it says value of k. The point A. So which one of those is it?
Will it be plus because you have to, a length has to be positive? Or
So as a vector, I actually think both are correct, to be honest. If it's a circle, then I think both will be right. Just want to see. Okay. Rationalizing it. Yeah, it is. It is both.
okay.
That's a strange one. It says value instead of values. Yeah, great. Good. So that was simultaneous equations by substitution, and a much harder one. Position vectors.
I think it's sick.
And so now it is this thing you mentioned, solving geometric problems. They use this lambda. I just use k, lambda and mu. Let's see this one. You know what? Just use your GCSE method and I think you'll be fine. Okay, let's try this one.
So do we need to do find AB first, and that'll be just minus A plus B.
Uh-huh.
And then we have to do something like minus A plus B divided by 3.
Yeah. And I think that's it basically. A to P is a third of minus A plus B. And I suppose you could expand it. Minus a third A plus a third B. And if you really wanted to, you could swap them around. A third B minus a third A. But same thing, it's just a third of that. Oh, something went wrong here. We forgot something. Yes. So that's A to P. How do we get the position vector of P?
Um,
Or what is the position vector of P?
I don't know. Is it like a third of A plus B, or
Just in terms of big letters, what does it mean by the position vector of P?
so O to A plus A to P, or
Yeah, so basically O to P.
okay.
So O to P is O to A plus A to P. We just found A to P.
Yeah.
And so go on. O to A.
And then O to A is just A.
And simplify.
So just 1 1/3 A plus a third B. Oh no. 2/3 A plus a third B.
Yeah, that's it. Okay, so position vector starts from O, origin, and so we just need to watch out for that. So we just have to add it in the A. Good. Let's see. Parallel. By comparing coefficients of parallel. If A and B are two non-parallel sides, and P2, what's that about? I think they're just putting it formally. Okay. How about this one?
Okay. So um okay. So do I need to first of all put on A and C onto the parallelogram, and then for and then if it's parallel, does that mean that AB will also be C
Yeah.
and BC will be A?
Yeah. CB.
Oh yeah, sorry. And then so would I have to do something like O to B is A plus C?
Yeah.
And O to B from the other side is also from the other way is also C plus A is A plus C. Sorry.
Yeah. So we have O to B.
So would I have to do something like A to C is C minus A,
Yeah.
and then B to O. What I'm doing really is I'm just guessing now. I need to just get some sort of thing. I'm not sure really.
What? Let's see. It's the point where they intersect. I'm just thinking, can we do P to O or O to P? Would we be assuming that that's half? We might have to assume. No, we can't assume that. Okay, let's see. Then, okay, so we can assume it. Okay, so P is halfway, and so how could you get O to P?
Oh, you could do half OB,
Mm-hmm.
and so would that just be half A plus C?
Mm-hmm. And what would that be if you expanded it?
Half A plus half C.
And what would you do next?
Would I do the same for B to P?
We did O to B, so I would do in the other direction.
Oh, A to C.
Yeah.
So that will I just have to do again half C minus A.
Yeah. So A to P. And expand it, what do you get?
Half C minus half A.
Yes. Okay. And do you just compare coefficients? Let's see, from the diagram, minus A plus C. P lies... Oh, hang on. If the diagonals bisect each other, it must be the midpoint. So that's kind of what we're trying to prove. Let's see. P lies on OB. So instead of saying a half, they just didn't assume a half.
Yeah.
They just said O to P is equal to lambda O to B, which is lambda A plus C. And then they did the same thing with the other, but they used mu, so as some other one. And so A to P is mu, and they're just using two, variables. They don't have any numbers attached. A to P was C minus A. Okay. C plus A, C minus A. P lies on O to P. P lies, so O to P. Let me go back here. O to P. Aha. That's a good way of doing it. So O to P, we said was this. Another way to do O to P would be O to A plus A to P.
Yeah.
And what would that be?
Would that be A plus O to P? Will that just be half A, half OB?
Yeah, and we'll just leave it as mu A to P. Sorry, mu A to C. Because we're proving that it's a half. Yep. And those two are equal to each other. But let me just see something here. Yeah, those are equal to each other. So that's C to A. Lambda equals 1 minus mu. And lambda equals mu. I don't see how you can say that. Oh, wait, hang on. So lambda mu. How do you get from one to the other? So they skipped a little step. So you could expand the bracket and then just say what is the coefficient of A, what is the coefficient of C.
Yeah.
Aha, so lambda A, this one has, so that would be equal to 1A minus mu A, and so you can divide everything by A. Lambda equals 1 minus mu. And same thing with the other one. And then go from there. Okay, alright, I'm abandoning that one. Let's see, this one, find the exact size of this angle. I just want to see if there's a similar one to that parallelogram one. Oh no, I did nothing like it. Yeah, this looks like... Okay, let's try This one.
Okay, so do I need to put the A onto JK?
So J to K is A.
And JL is B.
It's B.
So proof PR equals to half K.
And those are the midpoints.
Hmm. Do I need to do something to do with lambda or something like that?
I don't think so. I think we can do this just simple. What is P to R?
Half A.
So this bit P to J is half A. So P to R is P to J plus
J to R.
J to R. Okay, so what are those two?
Half A plus half B.
And that's a half B. For the A, you're going against the arrow?
Minus half A.
Yep. Okay. P to R is, that's what P to R is. How can we go about getting K to L? Or what is K to L?
K to L will be minus a quarter A plus a quarter B.
This is K, this is L.
Oh, right, sorry. Also, will it be two times that? Will it be minus A plus B?
Yep. What's next?
Um,
So from there, it's like it's so simple that it's kind of tricky. I just put this on the left side and then this on the right side. So hang on. No. Let's factorize PR.
so half and then minus A plus B.
Plus B. And so PR is a half minus A plus B. And I suppose that's literally equal to, yes. I suppose I should have, this line here. I suppose I should have just written it down here. Minus a half A plus a half B is, and then you just factorize it. And then you can see by substitution that this is PR.
Yeah.
This is a half. And what is this the same as?
PR.
No, minus A plus B.
Oh, B minus A.
Yep, but in terms of big letters, where did this come from?
That'll be KL?
Yeah. And that's what we had to show. I think that's it. So just get PR, just get KL, and factorize out the half to show that those are equal. Any questions there?
No.
How about part B?
So could you just say something like, because PR is a factor of KL?
Let's say maybe because it's just multiplied by a scalar.
Yeah.
It's just multiplied by a half. Let's see. Any two vectors where one is a scalar multiple of the other are parallel. Okay, and you're correct with your factor thing.
Yeah.
So a different way of saying it. Good. Okay, this is this lambda mu thing. Here we go. Let's try this.
Okay,
So A to B is A.
um,
So X and Y, wait, X and Z are the midpoints? Yeah.
and so does that mean that BC will be B as well, and A and DC will be A as well?
Uh-huh.
So will WY be something like will that be a third? Oh no, 2/3 A plus B minus a third A.
Yep. Was it simplified to it?
Will that be a third A plus B?
Mm-hmm. Part 2.
And then will that just be half B minus A minus B?
Minus a half B, I believe.
Yeah.
Yeah. What does that simplify to?
Just at minus A.
That one's minus A. Okay, question B.
Okay. So um so do I have to first of all find what the vector is of WY?
We did that, part 1.
So if that's a third A plus B,
Mm-hmm.
honestly, does that mean that WM is just equals to lambda a third A plus B?
Yeah.
So does that mean that WM? Wait, do I have to expand it, or
Yeah, eventually, yeah. Go
so
ahead.
I don't need to do it now, or
You can do it now, yeah.
so would it be WM is equals to a third A lambda?
I'll do it as third lambda A.
Okay. Plus a third lambda B.
Just lambda B.
Oh yeah, sorry. And then um um so do I now need to make that equals to I know. I'm not really sure what to do now.
They said, so WM is lambda times WY. So lambda could be a half, a quarter, 3/4. They said show that AM is this. So now let's try to get AM.
Okay, so will that just be like A to Z and Z to M?
That's one way. Try using the way we just found, which was the W going from W to M.
Um, will it be something like a third lambda A plus lambda B?
Mm-hmm.
And then do I need to take away the WA bit?
So big letters. How do you get from A to M? You said A to Z, then Z to M. Any other way?
Um, WM. Oh no, A to W, W to M.
Yeah. And that uses WM, which is what we just did. And so let's try that one.
So, um, so W to M is a third lambda A plus lambda B,
Mm-hmm.
and A to W will be a third A.
Third A. And so we want to so just factorize out what you can for the A's.
And then that'll be a third a third A.
Uh, you can factorize out A as well. So I'll factorize out the A to be at the end.
Yeah, a third, and then um 1 plus lambda.
Yes. And that was lambda B, and that's what they were looking for. So it's just basically something like this is what the A is, and this is what the B is. Okay, part C.
So um so do I need to find what X to M is?
X to M, yes.
So could I just do X to W then W to M?
Let's start with the mu X to Z. We found X to Z earlier.
Yeah, so X to Z is minus A.
And so mu X to Z.
Might just be minus mu A, or minus A mu, sorry. Or either.
Yeah, we put lambda and mu at the front because they're just standing for a number, whereas A is the vector.
Yeah.
And we put the numbers to the left. Okay, so X to M is that, and then X to M is also another way of getting there using something we used previously. Oh no, sorry. Find the A to M. Yeah, we want A to M. So anyway, you can get from A to M using X to M.
A to M. I'm not really sure what to do, sorry.
Or let's say big letters. How could you get from A to M? But you have to travel from X to M at some point.
So A to X, X to M, or A to
Yeah, A to B.
plus B to X.
Yeah.
Plus X to M.
Yeah. So what is A to B?
Just A, I think.
Yeah. B to X.
Um, half. B.
And we said that this was minus mu A. And so if that was some vector A, what would be the coefficient for A?
Minus a half. Minus me.
That'd be 1 minus mu.
Alright, okay.
This one is like 1A. So it's basically 1 minus whatever mu is A plus a half B. This one back here, they gave us that one up here. Hence or otherwise prove that M is the midpoint of W to Y and X to Z. X to Z.
So could you do something like if beta A is equals to minus A, then doesn't X to Z have to be the same equals to minus A as well?
Yeah, but that's kind of assuming it. We want to prove it. If M is the midpoint, then so actually we found A to M for part B.
Yep.
We found A to M for part C. And so what do you know about those two?
So I know what they are. So do I need to state what they are?
What do you know about them? The two answers that we found. If they're both equal to A to M?
Oh, so then they're both equal to each other.
Yes, they're both equal to each other. And so, what can you do with that?
Probably like rearrange the thing.
You can compare. So what do you notice? So what can you do with the coefficients of A? What do you know about those two?
Oh, does that mean that if one minus, do we have to get them on the same side or something? Or
Basically, they are equal to each other.
yeah.
So the coefficients of A must be the same as each other. And how about B?
So does that mean that uh, lambda u lambda b lambda b is equals to a half b.
Yeah. And
So it's just equals to a half.
So lambda is a half. And so how can you get mu?
Just sub in a half for lambda.
Yes. If you sub in a half and you expand it, I think you'll get mu is also equal to a half. And that will prove that it's the midpoint because it's halfway.
Yeah.
Killer stuff. It's the midpoint because it's a half. Yeah, that's a half. Any questions there?
No.
There you go. Solving geometric problems.
I'll give it like I think maybe like a half.
You asked for it. I'm not surprised you have difficulty with it.
Yeah.
So that's most of pure vectors anyway. We could always do the vectors in mechanics next time if you want, or we could do something totally different. Do you have any preference?
No, I don't mind. I don't think.
All right, we can pick some. Any questions for me in general?
No, I don't think so.
All right, well done, Andrey. You did great, and look forward to chatting again next week.
Yeah, cheers. Bye.
Have a good week. Goodbye.